extraction of zinc. Well, the chief ore for zinc is zinc blend. Its composition is ZnS. This is the chief ore of zinc, zinc sulfide. Now, let us see various stages in the extraction of zinc. Step 1 is concentration. This is done by froth flotation. Froth flotation. Here, remember, ZnS is always associated with PbS impurity. So, what you need to do is, first you add little pine oil, so that all the PbS will stick to the froth. Remove that. Now, you add excess of pine oil. This time ZnS will stick to the froth. PbS is more hydrophobic than ZnS. You know, Ksp of PbS is less than that of ZnS. Pb belongs to group 1, and in the qualitative analysis Zn belongs to group 4. So, remember that Ksp of PbS is less than that of ZnS. It has more tendency to stick to the froth. So, add little pine oil first and see to it that all the PbS is removed. Then you add excess of pine oil and do froth flotation to recover ZnS. Step 2. Step 2 is roasting. Here ZnS changes to ZnO. ZnS is oxidized to ZnO. You know very well, roasting is heating in presence of air. Oxygen present in the air will oxidize ZnS to ZnO. Now, step 3. Step 3 is reduction. We do carbon reduction. We have ZnO now with us. This is heated with coke. Then this becomes Zn, carbon monoxide is evolved. This burns with a blue flame at the mouth of the condenser. Zinc will distill out and will be collected in the condenser. Step 4. Refining. There are two ways you can refine zinc. A, thermal refining, and B, electrolytic refining. I will repeat these points. The chief ore of zinc is zinc blend, ZnS. It is subjected to froth flotation, but one small information regarding froth flotation of ZnS is associated with PbS. So, we do froth flotation in 2 stages. In the first stage, we add very little pine oil, so that all the PbS gets stick to the froth and removed. After this, we add excess of pine oil and recover ZnS. This is what you need to know about froth flotation. The second step is roasting. Here, we transform ZnS into ZnO by heating it in the excess of air. During roasting, moisture is also lost. Even any volatile impurities are present in the ore are removed, mass becomes porous. Then the third step is reduction. The ore is mixed with coke and heated to a high temperature, and this time ZnO becomes Zn. Coke gets oxidized to carbon monoxide and it burns with a blue flame. This shows an indication that the reaction is in progress. And when the color of flame changes, stop that reaction by putting mufflers, and then we do refining. There are 2 ways we can do refining. Thermal refining is one way of purifying zinc. Another way of purifying zinc is electrolytic refining. I want to elaborate on these 2 after some time. Let me add one point here. Impurities impurities present in the zinc are cadmium, lead and iron. These are the three metals which are generally present as impurity in zinc, and under refining we will be trying to find out how we will be able to get rid of these impurities from zinc. Look at this thermal refining of zinc metal. We start with the impure zinc. There are three impurities which are very often present: lead, iron and cadmium. We do distillation. Keep in mind that the boiling point of zinc is very less. We distill it at 920 degrees Celsius and zinc comes out along with cadmium. Lead and iron are left out. So, we get rid of these two impurities, lead and iron. These two are left out. What comes out is zinc along with cadmium. Now, we heat it to a temperature 767 degrees Celsius. At this temperature, cadmium volatilizes. Cadmium volatilizes, escapes out. What is left out is pure zinc. This is thermal refining. For your information, remember boiling point of zinc is 907. So, we are using a temperature, we are employing a temperature which is slightly greater than boiling point of zinc, and boiling point of cadmium is 765. So, we are heating it to a temperature which is slightly greater than that the boiling point of cadmium to remove cadmium. You can realize that boiling point of cadmium is less than that of zinc. So, that is the reason why we are evaporating out cadmium. So, this is thermal refining of zinc. Another technique available for the refining of zinc is electrolytic refining. Electrolytic refining. Here we use impure zinc as anode. Aluminum foil is used as cathode. So, zinc will get deposited on the surface of aluminum. Electrolyte is ZnSO4 plus dilute sulfuric acid. This is the electrolyte. On passing current, this happens at anode. Zinc will get oxidized to Zn2 plus by losing 2 electrons. It will enter into solution, and at cathode Zn2 plus picks up 2 electrons and becomes Zn. Now, one question which arises is, why are we using aluminum as cathode? Why not we are using zinc as cathode? The reason is the electrolyte is zinc sulfate and dilute sulfuric acid. So, zinc will dissolve in sulfuric acid by liberating hydrogen gas. To avoid dissolution of zinc in the electrolyte, we want anode to dissolve in the electrolyte, but we do not want cathode to dissolve in the electrolyte. Aluminum is preferred because it is a good conductor, and a layer of alumina on its surface will not allow aluminum to dissolve in dilute sulfuric acid. Aluminum will not dissolve in dilute sulfuric acid because of a layer of Al2O3 on its surface.